Hey everyone, this is Brandon coming to you with another physics tutorial. Hope that these problems can help you out. As always, I'll be posting a list of the equations we've learned up to this point on the web page, along with the questions I am working to help everyone follow along. Also, if you have any questions, comments, or concerns, go to the Contact Us page on our website and leave a response, or send us an email directly at bestudios.physics@gmail.com. So here goes nothing. Number 1. For the first problem, you don't really need to have any specific physics knowledge. It's more just problem solving and taking the average of something. So we're told that we're given the average costs of 3 different kilowatt hours that a homeowner is using and the amount of each type of power that they're using. So basically all we're going to end up doing is find the price that was paid for each of the individual types of power and then just divide that by the total number of hours to find the average cost per hour. So it says we don't need the guess method, and it would really be pointless because you'd just be writing out a bunch of different values. So all you really need to do is say that there's 905 kilowatt hours, and so that's times 0.105, and that's dollars per kilowatt hours, and that's going to be the total price paid for the 950 kilowatt hours. That's going to be plus 1127 kilowatt hours times 0.115. It's over kilowatt hours. And the main point of putting the over kilowatt hours is because the values will cancel and you'll be left with just dollars on top. So, and then for the last one, it's that, and that's times, the rate is 0.135 over kilowatt hours. And then what we're going to do is take all of the 3 numbers that we get from this and divide it by the sum of the different amounts of power. So 905 kilowatt hours plus 1127 kilowatt hours plus 2597 kilowatt hours. Because all we're trying to do is find the average. So up here in the numerator we found the total cost, and on the denominator we found the total amount of kilowatt hours, and we're supposed to find the average cost, and so all we do is we plug all of this into a calculator and we get the answer. And I'm just going to let you guys multiply those values together by yourselves, because it's basically just plugging into a calculator. And so the final answer you should get from all of that is $0.1243 per kilowatt hour. Alright, so that's a very simple introduction to this problem bank, which actually becomes a little complex. So we're just going to jump right into number 2. In number 2, we're introduced to something that you'll be encountering for the rest of this problem bank, and it's called a VIRP chart. What that stands for, it's the voltage, the current, which is represented by I, the resistance, which is represented by R, and the power, which is represented by the P. And so what you're going to do is it kind of explains how you lay this out in your problem bank, but I'm just going to go through it really quick. What you do is every time you have a resistor or anything in the circuit that ends up taking up power and changes the voltage and the current, you're going to put that over here on the left side of the table. So in number 2, we have 4 resistors. So we've got resistor number 1, number 2, number 3, and number 4. And in addition to that, you're going to have the total. And the total is basically you're going to be finding the total voltage, the total current, total or equivalent resistance. The total resistance, another term for that, is the equivalent resistance, and the total power of the circuit. So let me just draw a couple of lines, and once again I am sitting a little crooked while I'm writing this, so it's going to be a little slanted. Hopefully you can bear with me here. Okay, and so the first thing that we're really going to need to do, this was an introduction to the VIRP chart, but we're not really going to be filling in a lot of the values for this. In this problem, all we're concerned about is the resistance. And so it gives us the 4 resistors. Their resistances are 1 ohm, 2 ohms, 3 ohms, and 4 ohms. If you didn't know, this symbol is from the Greek omega, and it's basically representative of ohm, which is the unit of measurement for resistance. And what the problem wants is it wants the equivalent resistance if you have them wired in series, and then if you have them wired in parallel. And that value is going to change depending on if you're in series or if you're in parallel. And that whole thing is what is basically going to govern the rest of this unit. So when you have resistors that are in series, the equivalent resistance, or the total resistance, is just the summation of all of those resistances. So you've got resistance 1 plus resistance 2 plus resistance 3 plus resistance 4 in this case, because you have 4 resistors, and so those all contribute to the equivalent resistance. Now if you have them in parallel, what you end up doing is you're going to be finding the inverse of that, and you have 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And if you look on your formula chart that's in your booklet, you're going to see these two equations, but they're going to have a different look to them. They're just going to say like R and then have either series or parallel, and then have a summation of the resistances. Well, basically this equation is the same as that one, and this equation is the same as that one. And so you're just going to be using these for a lot of the problems later on in the problem bank. What we're going to do from here is basically just plug in the resistances, because what we're trying to find is the resistance in both series and in parallel. So if we just plug in the values, we have 1 ohm plus 2 ohms plus 3 ohms plus 4 ohms. And so you add all of those together and you end up with 10 ohms. And that is your final answer for when the resistors are all in series. If you have the circuit, you have a wire and then a resistor, and then a wire and then another resistor, and then a wire and then another resistor, more wire, another resistor. When we've got them wired in parallel, we have wires and resistors, and branching from that we've got more wires and resistors. So to find the resistance for this, we're just going to plug in that stuff. So we've got 1 over 1 ohm plus 1 over 2 ohms plus 1 over 3 ohms plus 1 over 4 ohms. And the answer that we get from that is 2.083. But there's a problem. We have this answer, yes, but that's technically over ohms because we have just a constant up here and ohms as the unit on the bottom. So ohms is still on the bottom. What we're going to end up having to do is realize that this is actually 2.083 over 1, or basically just take the inverse of that. And so when we take the inverse of it, that's just the x to the negative 1 button on your calculator. So it's going to be 2.083 inverse of that. And what we end up getting is 0.48, and that's in ohms. And so that is the resistance for when they are the total resistance for a bunch of resistors in parallel. Right, so hopefully I didn't lose too many of you guys on that. As always, any questions, don't hesitate to email us or fill out the form on our website. Okay, so now we're just going to move on to question number 3. In this problem, we're told that there are a couple of resistances in this circuit, and we're told that the potential drop, or the change in voltage, is 12 volts. And what we're supposed to do is find the amount of current in each of these individual resistors. Well, first things first, what we're going to have to do is use a VIRP chart for this. We were introduced to those in the last problem, but we never actually used them. So once again, I have the number of resistors in this. For this problem, I'm going to make this number 1, this resistor number 2, and that resistor number 3. Alrighty, do that, do that. Okay, so now that we've got our table, we're told in the problem that the total voltage is 12. That's 12 volts. And we know that the resistances are 3, 5, and 4. And what we're going to have to do is find the equivalent, or the total resistance, first. So what we do is we look at this, and anything that we can combine, we do. And so we know that there is a parallel circuit going on here because we've got a resistor down here and resistors up here. But these resistors are currently in series with each other. And so what we need to do is basically find the total resistance for the two of these individual resistors, so we can make it look like there's only one resistor on the top. And when we have one resistor on the top and one resistor on the bottom, we can then use the inverse rule, and we can find the equivalent resistance that way for a parallel circuit. So what we end up doing is we have the wire, it splits, we've got one resistor, and that is 3 plus 5, so we have 8 ohms. And then down here we have 4 ohms. Alright, and so from here all we need to do is say 1/8 ohms plus 1/4 ohms is equal to 1 over 2.67. All I did there was I plugged these into my calculator, and the answer I came out with was 0.375, and I took the inverse of that. And the inverse of this is basically just that number. Alrighty. And so with that, with the 2.67, we know that the total resistance of this circuit is 2.67 now. Once we found that resistance, the thing that we can do is basically redraw this whole circuit as a single resistor